Okay, here's a video for 4.4 practice A, and this is a section on factoring. So there's quite a bit in factoring. There's quite a few things that you got to look for, and we've built on these since Algebra 1, and so the last few we're working on are new to Algebra 2, but it's a good recap. There's like 6 things that you should always look for when factoring, and factoring just really means to break something into smaller pieces so that it's easier to manipulate, easier to solve. So that's what we're going to do. We're going to factor, we're going to break things down. So first, we should always look for a GCF, a greatest common factor, any number that you can divide out of every single term. Next, you should always look for a difference of perfect squares. If there's 2 terms, they might be perfect squares, and there might be a minus between them. Then there's an easy way to factor that. 3, we might look to do the x. That's if there's no number in front of x squared, then we would put the last number on top, the middle number on the bottom of our x, and then we would find the factors. You might need the star method, which means there is a number in front of x squared. Like you see this 2 right here in front of the w to the 4th or whatever. We might need that. We would use the star. We could show you that. If there's 4 terms, we want to use what we call the box. And 6 terms, number 6 means you might have a sum or a difference of cubes. You're going to see that here on 7, 8, and 9. So let's check out the first 6, and we'll see what they look like. All right, we'll start number 1 over here. The first thing I want to do is show you that there is a GCF. We can divide everything by x. So if you can, you should divide out a common factor. So that common factor would help us make it smaller to begin with. So we would end up having an x as our common factor. What's left over is x squared. Because you had 3 x's, you took 1 out, so now there's only 2. The middle term had 2 x's, you took 1 out, now there's only 1. And the last term had only 1 x, so you took it out. So that's what would be after you took out an x from every term. That's a GCF. Now I'm seeing 3 terms here. My mind automatically goes to the star since there's nothing in front of that x squared. It's like a 1. I'm going to put the negative 12 on top because that's this last term right there. That's what we put on top. The middle term is negative 1. I need to multiply to get negative 12 and add up to negative 1. So that would be a negative 4 and a positive 3. If you multiply those 2 numbers, you get negative 12. If you add those 2 numbers, you get negative 1. So those are my factors, x minus 4 and x plus 3. And that would be your answer to 1. Number 2, 9p to the 7th minus 36p to the 5th. And now you might notice there are at least 5 p's that you could divide out of both sides. So we should do that. We should divide out a p to the 5th. I could actually show that to you up here, p5 and p5. These would cancel out. These would cancel out, but you would still have p squared up here on the top because you had 7, you took away 5, now you've only got 2. Okay, so back over here, this would be p squared minus 36 because these will cancel out. 5 of these cancels with 5 of those, you'd still have 2 on top. Now you look for that difference of 2 perfect squares. This is a perfect square. It's p times p. This is a perfect square. It's 6 times 6. So to factor a difference of squares, it's p plus 6 and it's p minus 6. It's these 2 6's go in the back, the 2 p's go in the front, and because it's a difference, that means you need different signs. You need a plus and you need a minus. Okay, so there is number 2. Number 3. We have a GCF again. All of these are having GCFs. You could divide all of these by a 3. And all of them have at least 4 ends. So what you'd have is a GCF of 3 . n to the fourth. What's left over then would be an 11n's. No, that's the middle. First term would be just n squared, sorry. N squared, and then it would be minus 11n. And then it would be plus 24. Okay, now that's another x. There's no number in front of n squared now. It's gone because we took out the 3. So 24 on top, negative 11 on the bottom, negative 8 times negative 3 gives us a positive 24 when we multiply. And it gives us a negative 11 when we divide, or when we add. We add, we get negative 11. So your two factors are x minus 8 and x minus 3. Those are your two factors. Just looking for factors right now. Break it down into smaller pieces. And number 4, I'm first always going to look for a GCF, which again, this one has another GCF. So you could divide out a 2 and a k to the 4th, no k squared. They both have at least 2k squareds in them. So number 4, you've got 2k squared, and then you've got what's left over is just k squared minus 121, which these are both perfect squares, k times k and 11 times 11. So you've got to bring down your GCF in your answer. K plus 11 and k minus 11. Remember, when it's a difference of squares, there's different signs in there. And that reminds me, I don't know if we brought down our GCFs in the other answers. That one would have an x in front of it, that first one. So this guy right here, it should be an x in front of that GCF. There you go. Number 2, there was a p to the 5 in front of our answer. P to the 5th was our GCF. Okay, number 3, our GCF was a 3n to the 4th. So we should put that in there as well. 3n to the 4th is what we took out. All right, now we're in good shape. Always put your GCF in your answer. All right, number 5. There is a GCF again. It is 2 W's. You got at least 2 W's in all of them. So you can take out 2 W's or W squared from every term. Okay, so let's do 5 underneath number 2. Okay, so we have W squared is our GCF. So what's left over would be 2W squared minus 7W minus 15. So all of them get taken out 2 W's. That's what would be left over. Now this one you can see has a number in front of your x squared. So we're going to need to use what we call the star method when there's a number in front, because you've got a 2W here to contend with. So that has to go here on the top of our star. When you multiply the first term times the last term, that's a negative 30. That's what's going to go on top here. So it's a 2 times a negative 15. That would be negative 30. The bottom number is a negative 7. So we need two numbers that are going to multiply to give us negative 30 that add up to negative 7. I'm thinking negative 10 times a positive 3. When you multiply, you get negative 30. When you combine, you get negative 7. Now the star requires us to look to reduce. So 2 and 10 can be reduced to 1 and 5. So 1 parentheses, let's bring down our W squared. 1 parenthesis is W minus 5, because you got the W here and you got the negative 5 there. The other one cannot be reduced 2w plus 3 cannot be reduced. So we just leave it. If you can't reduce it, you just leave it. So that was 5. 6. Let's go to 6 so you can see it right up here. Let's see. GCF, it looks like it's just q to the 4th. Nothing goes into 17. So q to the 4th, unless it was 17, but we don't have that. So our GCF is q to the 4th. What's left over is 3q squared, because we took out 4q, so it leaves us with 3q squared. The middle would be negative 17q, because there was 5. We took out 4 of them. There's just 1 left. And minus 28 for the last one, because we took out the q to the 4th. Again, there is a number in front, so again, I need my star method, where my 3q is on the top of my star, because it's the beginning. Multiply 3 times 28, negative 28. That's going to be negative 84. Add to get negative 17. So what multiplies to give us 84, but combines to give us negative 17? That's a good question. So we try some of them. 20, let's see, 2 times 42 is not going to give us 17. So how about 4 and 21? Yes, that will work. I would need the negative 21 and the positive 4, because if the bottom one's negative, the bigger one's got to be negative. And that can be reduced. 3 can go into 21 7 times, so w minus 7 is one of my answers. Not w, sorry, q. Q minus 7. Okay, there's my q, there's my negative 7. 3q plus 4 is my other one. That's right there. And then we need the q to the 4th power to be in our answer as well. So there's your solution for number 6. That's factoring. Those are just factoring. Now, sum and difference of cubes. We have a little chart over here. Now, a cube is like 2 times 2 times 2. That would be like an 8. 8 would be a cube, because 2 times 2 times 2 would give you 8. A times A times A gives me A cubed. To factor out a sum of cubes, that means the first little parenthesis is sum, and then you get your negative. So if it's a sum of cubes, then you do sum and then negative. If it's a difference of cubes, then you do different and then positive. So that's how those work. So let's take a look at what they gave us in 7. Okay, and you really don't have to do a lot of work on these. This is a cube, x times x times x. This is a cube, 3 times 3 times 3. So we are going to use the sum, which is this one right here. So a plus and then a minus. Okay, so we want to do a plus first. So we want to do x plus 3. Then we want to do x squared, and then we want the minus. And then we want the 3x and the minus 9. Okay, this is my A number here. This is my B number over here. And you can see that that's kind of how they use it on this little picture. Is your first number is your A number, your second number is your B number, and then A squared, A times B would be, for me, it would be x times 3. If x is A and B is 3, it would be x times 3. But it's a minus because we have to do a minus because the other one was a plus. It's a difference of a sum of cubes. We have another sum of cubes in number 8. Another sum of cubes, which is, this is y times y times y. This is 10 times 10 times 10. So we just want to plug it into our formula. First one is going to be a plus b. That would be y plus 10. Then it would be a squared, which is y squared, minus the a times b, which is 10 times y, and then plus the b squared, which is 100. So there's my factoring for number 8. This one was my factoring for number 7. And then number 9 is a difference of cubes. So we have W times W times W minus we have 5 times 5 times 5 is 125. Okay, so in this one, you want to do the A minus the B this time. And then A squared plus AB plus B squared. So that's just in the charts. Oops. It's just in the chart that I showed you right over here. When it's a difference, the first one's a difference. That's what I put here, difference. And then the next one in there's a plus. So plus and then a minus, and then another plus. So plus and plus. That's when you have a difference of cubes. All right, number 10 is just a factor, and it's got 4 terms. So we use what we call the box. You can see I put that up here at the top, the box. We've done sum of cubes and difference of cubes. Now we're going to do the box, 4 terms. I just think the easiest method to factor with 4 terms is to use the box method. So I'm going to do it over here. I'm just going to draw a box, and I'm going to put 2 lines in it, and I have 4 places. So because I have 4 terms, so I'm going to put y cubed in the first one. Straight across, you get negative 3y squared. The first one on the bottom would be positive 4y, and then negative 12. Now you want to look for GCFs. So you want to look across, and you're going to see that they both have y squared in it. If you look at the top 2. If you look at the bottom 2, they both have a 4 in it. You could divide them both by 4. If you look at this column, the first column, they both have a y in it. If you look at this column, they both have a negative, and they both have a 3, because you can divide them both by 3. So there's your 2 parentheses, y plus 3, y squared plus 4. So y minus 3 and y squared plus 4. That's how the box works. And it's pretty much the same on all of those. So there is one little trick, though. Let me show you 13. Because I want to show you what happens when you got 2 negatives in the middle. So you got x cubed, negative 6x squared, negative 9x, and positive 54. So if you were just to do this like normal and look for GCFs, this would have an x squared in it. They both have at least x squared. This bottom one would have a 9 in it, because you could divide 54 by 9 and 9 by 9. So that's the bottom one. The top left column has an x in it. They both have at least x in common. And down here, these both have a 6 in common. But if you were to leave it like that, you would have x plus 6 here on the bottom, and you'd have x squared plus 9 on the right side, and that can't happen. Because if you were to do FOIL, you would get all positive numbers, and yet you had 2 numbers in here that were negatives. So the one little trick is when your 2 middle terms are negative. When these 2 are negative, that's going to make the 2 inside negative. So both of these are going to be minus. It's the only way that actually works. So that looks done, except we do have a difference of perfect squares right here. This is x times x, and this is 9 times 9. We always want to get the smallest possible. We don't really want x squared if we can help it. So we're going to get x plus 9 and x minus 9. There you go. Now it's completely factored, and there's nothing higher than an x. So that's 10 and 13. 11 and 12 are going to be just like number 10. So you just got to look for GCFs. So you don't have to put those on your notes. But you do have to do them on practice B. All right, let's go to 14. Factor completely. Okay, so we always want to look for a greatest common factor if possible. I'm going to do 14 down here at the bottom. So we have 36p to the fourth minus 25. This one is actually no GCF. It is a difference of squares, though. 6p squared times 6p squared would make 36p4, and 25 is 5 times 5. So your best answer would be 6p squared plus 5 and 6p squared minus 5. That would be your best solution because you have your 6p squareds that go in the front and you have your 5s that go in the back, and then you got a plus and a minus. We'll cancel out your middle terms. Let's see, number 15, I think we can just do right inside of here. It's pretty quick. 28 goes on top. 11 goes on the bottom. 4 times 7 would be 28. 4 plus 7 is 11. So you're going to get a positive 4 and a positive 7. But it's not going to be n. It's going to be n squared because your middle term has a square and this one has a 4. So when you multiply the first two terms, you've got to get n to the fourth. The only way to do that is to have n squared times n squared. Okay, so that'll get you your n to the fourth. Okay, so n squared plus 4, n squared plus 7. That middle term is n squared. That's what those two front ones have to be. And then 16, you've got two perfect squares. This is y squared times y squared. This is 4 times 4. So y squared plus 4, y squared minus 4. But this has another perfect square, y times y and 2 times 2. So not only do you have the y squared plus 4 answer, which doesn't factor, but the difference of squares does. So y plus 2 and y minus 2. Remember, this one is because it's a minus, we can factor it. This plus means you can't factor it in the first one. When you got a plus right there, you cannot factor the first one, but you can factor the second one. So you would actually get 3, you would get 3 parentheses here. And it's kind of ugly over here, so let me fix it. Y minus 2. So this is your answer right there. So instead of just 2 parentheses, you actually have 3, because this y squared minus 4 was a difference of 2 perfect squares. All right, last 4 here are wanting to know, is this a factor of this? Is this one right here a factor of this? The only way to tell that is to use synthetic division and see if there's no remainder. And then you'll know that it is a factor. If you remember synthetic division, we want the opposites of that number right there. So we want negative 5. And then we got to put these numbers in. 3, 7, negative 8, and negative 5. 3, 7, negative 8, negative 5. So bring down the 3. 5 times 3 is negative 15. Combine those, you're going to get negative 8. That's going to give us positive 40, which is a positive 32. And then negative 5 times 32 is negative 160. When you combine those, you're going to get a negative 165. So this one is definitely a no. We're looking for one that comes out with 0. So 17 is a no. It has a remainder, so it doesn't work. Well, let's try 18. You need the opposite of this 9, so you need a negative 9. 2, 15, negative 23, and positive 36. So let's bring down the 2 Negative 9 times 2 is negative 18. That's going to give you negative 3. Negative 9 times negative 3 is positive 27. That's going to give you a 4. Positive 4. And then negative 9 times positive 4 is negative 36. That's going to cancel out and give you a 0. So that checks off. That means this is definitely a yes. It's a yes if you get 0 remainder. And synthetic division, I believe, is the easiest way to do these. So again, we want the opposite of x minus 2. Opposite would be a positive 2. And then the four numbers are 6, negative 8, 6, negative 8, negative 6, negative 4, because they're right here in the equation. 6, negative 8, negative 6, negative 4. We see them right in the equation. 6, negative 8, negative 6, and negative 4. I'm kind of squishing it in there. All right, let's do our division. So we bring down the 6. 2 times 6 is 12. Combine these, and you get a positive 4. 2 times 4 is 8. When you combine these, you get a 2, a positive 2. 2 times 2 is 4. Negative 4 and positive 4 cancel out, get 0. So this has no remainder, so 19 is a yes. And last but not least, number 20. Okay, we need the opposite of negative 6. Opposite of negative 6 is positive 6. And then we have 12, negative 69, 39, and 30 as my four numbers. So bring down the 12. 6 times 12 is 72. When you combine these two, you're going to just get a 3. 6 times 3 is 18. When you combine that with 39, because it's positive 39, 17 carry the 1, you get 57. 6 times 57 is 42 carry 4, would be 342. That will not work. That would be 372 as a remainder. So this is definitely a no. It does not go in evenly. You'd have to get it to go in where your remainder would be 0. All right, so let's see. You don't have to do the last 3 there. When you get to practice B, you don't have to do the bottom 2. And I actually gave you all your answers here. But answers are here, but you need to show work on these to how you got these answers right here. And then your answers for the puzzle are in the puzzle. So good luck for it on 4.4. Remember, try to finish strong.